Hi, welcome to section 5.3 where we're going to talk about the area of the triangles, parallelograms, and trapezoids. Okay, the bell ringer we did in class, so you're going to need to get that from a classmate. So our first objective is to talk about the area of triangles. So we have some terminology to talk about. We have three triangles. We have a right triangle, and we'll call that case 1. We have an acute triangle, and we'll call that case 2. And obtuse triangle, we'll call that case 3. So case 1, case 2, and case 3. Alright, so our first terminology is the base. The base is the bottom leg or a leg that just forms one of the right angles. The other one is called the altitude. The altitude is the other leg that forms the right angle. So that's the altitude, and that's the base. Another name for altitude is height, so we use the letter H, and then for base we use B. Okay, so now what we're going to do is we're going to look at case 2. We're going to look at the acute triangle. So the bottom is called the base as well. And if I draw in the line that forms a right angle to the base, that's the altitude or height. Okay, and in the obtuse, it's the same thing. So we have the bottom, which is the base. Now we have to form a right angle. So to form a right angle, we have to meet on the outside. And so our altitude will be this line right here. And it forms our right angle. This piece right there, that has nothing to do with the base. It's only the distance from the triangle to the altitude. Okay? Alright, so that's the terminology. So what we're going to do is we're going to prove the area for each triangle. And we're going to start with case 1, a right triangle. So let me put my right angle in, and let me label my B for base, H for height or altitude. Alright, when you're finding the area of triangles or anything, and you want the students to actually understand what it is, make sure you always relate it to prior knowledge. Now, prior knowledge is that the students know the area of a rectangle. So what we're going to do is we're just going to continue this rectangle. And the students know how to find the area of a rectangle. So area of the rectangle is equal to length times width, or in other words, base times height. So they can use a little bit of logic, and they say, well, the area of the triangle is just half of that, and that's all we have to write. So the area of a triangle is equal to 1/2 base times height. And that's what we want, because that is the proof for the area of a triangle. So we want that equation for all three cases. So our next case is an acute triangle. So first of all, let's draw in our altitude. And here's my right angle. So that means we could do a little bit of labeling. This would be my base, so my B, and my altitude is H for height. Alright, once again, we're going to relate it to some prior knowledge. And some prior knowledge would be that we continue our rectangle. And if you could see, we have 4 triangles that are made. We have triangle A. I'm going to call this A prime. I'm going to call this one B prime. And we'll call this one B. So A prime, and B prime. Okay, if we look very carefully, we're going to look at this. I cover that up. I have a rectangle, and A and A prime are equal to each other. So we know that triangle, the area of triangle A is equal to the area of triangle A prime. Alright? And so we could use the same argument about B and B prime. So the area of triangle B is equal to the area of triangle B prime. Alright, so then we can make the argument that if I add A and B together, then that's going to be the same as if I add A prime and B prime together. So we could say the area of A prime plus the area of triangle B prime is equal to the area of triangle A plus the area of triangle B. Okay. Well, and we'll put a little triangle in there. There you go. Well, if they're equal, then that means that the area of A prime and B prime are just half of the rectangle. So therefore, my area of my entire triangle A prime, B prime, we'll call it A prime, B prime, is equal to 1/2 times the area of the rectangle. And we know that the area of a rectangle is 1/2 base times height, or is base times height. So that's equal to 1/2 times my base times my height. And that's it. Okay, so that's an acute triangle. So now we're going to look at case 3. Case 3 is an obtuse triangle. And what we're going to do is we're not going to relate it to rectangles this time. We're going to relate it to right triangles. So first of all, we got to see our two right triangles that we're talking about. So I'm going to do some labeling. I've got A, B, C, and D. And here's my right angle. My first right triangle I want to talk about is my big one on the outside, which I just highlighted in blue. So we know, and I'm going to do some labeling, my total distance here is, I'm going to call that X. Remember, my base is from here to here, so I'm going to call that B. And then this little distance I'm going to call X, and then I'm going to label my height H. So we want to first talk about the area of triangle A, B, C. Well, that's equal to 1/2 times my base, but my base is the whole thing, so it's me X, H, because my height. And I'm actually going to rearrange that and make that 1/2 H times X. And it'll make a little bit of sense why I did that here in a minute. Okay, now what I'm going to do is I'm going to look at my little right triangle, which is right here. And I labeled some stuff wrong. This can't be an H. It has to be, or that can't be a X, so I'm going to make it a Y. There we go. Alright, so the area of triangle ADC is going to be equal to 1/2 its base. Its base is y, and its height is h. And once again, I'm going to rewrite it in a different order, hy. Okay, so what we're looking for is we are looking for the area of triangle ABD. We're looking for that triangle right there. In order to find that triangle, all we have to do is we have to take the big triangle and subtract the little triangle. So, area of triangle ABD is going to be equal to the area of triangle ABC minus the area of triangle ADC. So what we're going to do is we're going to plug some stuff in. Let's move my C over. Area of ABC, we found that to be right here. So that's equal to 1/2 HX. Area of ADC is right here, is 1/2 HY. Now we can factor out some stuff that's in common. We could take out 1/2 H. So if I take out the 1/2 H, I'm left with X here. Take out 1/2 H, I'm left with minus Y. Okay, but we know that B, this distance right here, is equal to my entire distance, which is X, minus my little distance, which is Y. So by substitution, we could say that we're equal to 1/2 H. Instead of having X minus Y, we have B. And that's the proof for an obtuse triangle.